Thanks very much, everybody, for joining us. Welcome to the University of Maine Artificial Intelligence webinar. My name is Abedi, Assistant Vice President for Research and Professor of Electrical and Computer Engineering at the University of Maine. I will be moderating this webinar with my colleagues from College of Engineering and School of Computing and Information Sciences. It is now my great pleasure to introduce Dr. Joan Ferrini-Mundy, President of the University of Maine and its regional campus, the University of Maine at Machias. President Ferrini-Mundy holds a PhD in mathematics education from University of New Hampshire. She came to Maine from the National Science Foundation, where she served as Chief Operating Officer. Her distinguished career spans the field of mathematics education, STEM education and policy, teacher education, and research administration. President Ferrini-Mundy is a member of the Board on Higher Education and the Workforce of the National Academies. Please join me to welcome President Ferrini-Mundy to our virtual podium.
Thank you very much, Dr. Abedi. Good afternoon, everyone. It's a pleasure to be able to welcome you all to this first ever webinar on artificial intelligence sponsored by the University of Maine Artificial Intelligence Initiative. I'm sorry that we're getting together under these very difficult circumstances, but delighted to be able to be part of initiating a conversation among all of you that I hope will continue well beyond this event. As our world is rapidly changing, particularly through this pandemic, the reliance on digital software, applications, AI, all of that is impacting us on a daily basis and will impact us in untold ways as we look toward the future. So being able to do that well, whatever we're called upon to do, from online banking and streaming videos to autonomous vehicles, to detection of cancer, to a host of health-related applications, AI connects the world. The University of Maine Artificial Intelligence Initiative, which is UMaine AI, is dedicated to the advancement of AI and its applications in response to the needs of the state of Maine. It is a unique Maine-based venture that brings together university, industry, government, and community collaborators from Maine and beyond to advance the field of artificial intelligence, and in particular to advance its applications and to promote its application in fields where it is not yet fully applied. The initiative leverages our university's strengths to bring a multidisciplinary approach to solving problems through cutting-edge research, and also, of course, leverages our wonderful partnerships across the state and beyond. This webinar will feature a diverse panel of AI experts working in education, research, and industry to present on advances in AI, applications of AI, excuse me, education and workforce development, and social, ethical, policy, and legal considerations related to AI. Thank you very much for joining us.
Thank you very much, Dr. Ferrini-Mundy. Before we start the panels, I just would like to remind all the attendees to please keep your microphones on mute and your videos on off unless you're presenting. You can use the Q&A option at the bottom of your screen to post your question, and at the end of each 30-minute panel, the moderators will ask your question from the panelists. So now the first panel will be moderated by Dr. Terry Yu from the School of Computing and Information Sciences. Terry, please take it away.
Thank you very much. My name is Terry Yu, as Dr. Abedi said, and I am an associate professor in the School of Computing and Information Science. They're a very exciting panel to start off this session today. I'm joined by three distinguished panelists, Roy Turner, Salome Yasaseke, and Carla Bradley, and I will be introducing each in turn. For some reason, I have lost my capacity to see my screen. Our first speaker is Roy Turner. He'll give us a brief statement, and we'll then go through the other panelists. The format is we'll go through the other panelists, each giving a brief statement, and they'll take questions and answers. Roy was a graduate. He got his PhD at Georgia Tech University, and later was a visiting research professor at the University of New Hampshire and Northeastern University before joining the faculty at the University of Maine. He has the most seniority, one of the professors with the most seniority in our School of Computing and Information Sciences. He is also the principal investigator for a major research initiative program, instrumentation program grant from the National Science Foundation. Roy, to you.
I've been asked to give a bit of an overview of what artificial intelligence is and kind of frame the discussion a bit. AI is kind of misunderstood in many ways, but what it is an area of computer science whose goal is basically to give computers some abilities they currently don't have. For example, to allow them to do things that require intelligence. So for example, medical diagnostic reasoning, legal reasoning, planning, fabrication of objects, things like that, all of which can be done by AI. And to do the things that animals and humans can do very easily, but are extremely difficult for computers. So for example, to examine an image and detect things in an image, to, and to understand natural language, the things that we can do easily, but computers can't. There's a huge number of AI areas and techniques, but I'm not going to go through all of those, obviously. Automated reasoning being one, which includes things like theorem proving and planning and scheduling, controlling intelligence, like Tesla cars, things like that, or drones, interpreting sensory information. So for example, natural language processing, computer vision, but also in that category. Knowledge-based or expert systems. You've probably all been under the scrutiny of an expert system at one time or another when you had credit card transactions or you applied for a loan or something like that. And then the most burgeoning area at the moment, machine learning, that Salome will talk about in a bit. So what can AI do? Well, web search is one thing that we interact with on a daily basis. In fact, Google is primarily an AI company. One of my colleagues is the chief or the vice president for search quality out there, and he's got a PhD in AI, for example. Intelligent control, he's mentioned that for drones and self-driving cars. Planning complex operations like getting material where it needs to be for wartime activities or planning factory things. Medical diagnosis, car diagnosis, things like that, natural language processing, all sorts of things that are becoming important. Sentiment analysis, for example, for social media to pick up on hate speech and that sort of thing. Data mining for large pieces of data. The question arises why, since AI has been around for arguably 100 years, but really since like 1956, why AI right now? Why an AI initiative? Well, it's a confluence of three things primarily. We've got great societal needs at the moment, many problems facing us that are simply beyond what we can do without some help from automation. So for example, climate change, even the COVID-19 pandemic, all sorts of things that are coming up now that need significant amounts of resources and analysis. We also, for the first time, have tremendous amounts of data, not only that needs to be processed, but that can be used in order to train artificial intelligence systems. And finally, in the last decade or so, people have made tremendous advances in the algorithms behind machine learning. In addition, there have been advances on using the kinds of processors that we have in our computers, the GPUs, which are basically just supercomputers, to use those for our algorithms. And so this has all come together nicely in the last 10 years or so. To see another reason why, this is the predicted economic impact of AI in millions of dollars. We're right about here. If you can see my pointer, if not, we're in 2020. And you can see it's expected to be an exponential growth curve for the impact. Venture capital, which these people are not stupid, they put their money where they think they're gonna get some reward. Again, an exponential increase. So lastly, why AI, why UMaine Artificial Intelligence Initiative? Well, we've got active labs in AI research, for example, the Sky Lab, Seke's lab, and the Mainsail lab. We have very good collaborators, most recently the Rue Institute, which Dr. Bradley will talk about. There's a host of applications ongoing on campus already. These are all applications that people are using AI for on campus. There's applications across the state as well. We have quite a bit of resources, as Thierry alluded to. We had a major research initiative grant that's going to install a petaflop GPU cluster, which that means basically quadrillions of instructions per second, primarily for artificial intelligence. And finally, as part of Maine's outreach mission, we're uniquely situated to reach out to K-12 to begin to educate the workforce on artificial intelligence, this emerging technology, to help the industry in the state, the government, and fisheries, et cetera. All right, thank you, Terry.
Our next speaker, our next panelist is Salome Yasasekev, going from one of our most venerable faculty to one of our newest hires. In fact, she is our newest hire in the School of Computing and Information Science in the Computer Science program. Dr. Yasasekev is an assistant professor of computer science, and prior to joining our faculty at the University of Maine, she was postdoctoral research fellow in the EECS department at the University of Michigan, Ann Arbor. She has also had appointments in Brazil and Italy. She is the director of the SECA Lab, focusing her research on designing and analyzing machine learning algorithms, deep learning techniques, and the application of machine learning techniques in real-time problems. Dr. Yasasekev.
Thank you, Terry. Okay, good afternoon, everyone. I hope that you can see my slides. So I'm going to talk about advances in AI from algorithm design and machine learning perspectives. Given the exponential rise of interest in AI, experts have called for major studies in developing AI approaches. Last recent decades, researchers have been working on designing and analyzing methods that are capable of beating human experts in different fields. However, the coming era of AI brings prominent challenges of smart methods with low risk and computational complexity. This is because digital life demands acceleration and accuracy in processing this algorithm. In SECA Lab, we actually address these type of challenges. So machine learning, specifically deep learning, has become a massively important field in recent decade. And this is because of its application, its fascinating applications in many modern real world problems. So in SECA Lab, we advance deep learning techniques, we improve them, and we actually try to extend deep learning architectures, as deep networks are extremely intensive in terms of both computations and actually memory usage. We explore their applications in various domains and disciplines, so like computer vision, climate change, forest science, and so on. In addition, in SECA Lab at University of Maine, we develop AI techniques that makes computers creative, like adversarial attacks in machine learning. But this is not only our mission in SECA Lab. In SECA Lab, we actually rely on AI and online machine learning approaches. We design time series methods that actually analyze the big and massive streaming data. We live in a world of streaming massive data, and time series algorithm and prediction play an important role in the future of AI. Therefore, in SECA Lab, we design online streaming feature selections technique that are applicable in problems like autonomous car, or in video streaming, or in movie streaming companies. In addition, we actually focus on time series deep learning as new technology that supports large-scale streaming data and save human lives. We leverage time series deep architectures and explore their applications in many real-world problems. As a side project, actually, here at University of Maine in SECA Lab, with my machine learning team, we are working on COVID-19 forecasting locally and globally by using these time series deep learning architectures, and with the hope that we will be able to help humans and save some lives. Thank you, Terry, and I'm happy to take the questions later.
Thank you, Salome. The University of Maine is also both grateful and and happy to have Carla Bradley, the Dean of the Corey School of Computer Sciences at Northeastern University, join us this afternoon. Prior to joining Northeastern as Dean, she was professor of the Department of Computer Science at Tufts University, and before Tufts, she was on the faculty of the School of Electrical Engineering at Purdue. She's a fellow of the ACM and a fellow of the Association for the Advancement of Artificial Intelligence. She has co-chaired or been program co-chair for AAAI, as well as the International Conference on Machine Learning. She is currently a board member of the CRA, the Computing Research Association, and she's a member of the advisory committee for the National Science Foundation's Directorate of Computer and Information Science and Engineering. Please welcome Carla Bradley.
Thank you, Terry. First of all, I'm very honored to participate in this webinar today. And in particular, my background of research is in applied AI. And one of the things I love about the directions that you're speaking about, and of course, the really incredible research that we just heard about, is the fact that when you do applied AI, you have the ability to make a huge scientific impact in the field that you're applying artificial intelligence. And you also have the ability that through that application, you uncover areas where AI has not progressed far enough to solve that particular problem. I want to ground that with two examples from my own research. The first was with New York University's Epilepsy Center, where we were trying to find the lesions in treatment-resistant epilepsy patients that were causing their seizures. A treatment-resistant epilepsy patient is one where the drugs don't work. Now, I didn't know this prior to the collaboration, but it turns out that the only way that you can solve this problem is through a process called surgical resection, which is where you scoop out the bit of the brain that causes the seizure. Of course, you have to check that it's not a place that you really need. And although I was invited multiple times to watch the operation, I have declined in all cases. So what did we do? Well, it turns out that the lesions that cause this that are typically on the cortical surface, and expert neuroradiologists can't see these lesions. So we took a machine learning approach to this, and we were able to get the efficacy of our ability to find the lesions up to 80%, whereas before it had been 20%. Now, if you can find the actual lesion, then the efficacy of the surgical resection goes from 29% to 66%. And I can tell you, if you're telling me that I should have an operation on my brain, 66% sounds a lot better than not 66%. Obviously 100% would be better. But in creating this, in applying machine learning, we had to develop new machine learning methods that were then published in the AI literature that were applicable to other problems. A second example, and one that I think will resonate with Maine in particular, is we looked at how do we use machine learning to create maps of global land cover from satellite data. So what's on the Earth's surface? This is a very challenging problem because you only have a set of data to work with that the satellite can produce. And we were able, through our application, to figure out that the 17 land cover classes that have been dictated by the whole community were not actually as representative of what's going on in terms of what could be distinguished by the data. So for example, agriculture really needed some finer distinctions for the different types of agriculture, and the distinction between mixed forest versus coniferous forest was not able to be ascertained from the spectral data. So, and again, we invented a new machine learning method that looked at how do we use both the raw data and then the data that had been labeled to come up with a new definition of land cover classes. So I love this applied focus. It's going to lead to wonderful inventions in basic machine learning and AI. Now, on behalf of Northeastern University, I want to say that we're extremely excited to join the Maine ecosystem with the RU Institute. The focus of the RU Institute is applied human-in-the-loop artificial intelligence, And in particular, we are really excited to build partnerships with AI faculty and then faculty from the areas of excellence in Maine. And I apologize if I leave any out, but such as forestry, the Climate Change Institute, composite materials, pulp and paper, and then of course all of the many initiatives around marine science that the University of Maine is so well known for. We're really excited to create joint government and industry funded research. And as part of this beginning of our collaboration, we are hoping that we build up a synergy where Maine faculty might spend sabbaticals at the Rue Institute and vice versa, that we have visiting fellowships for PhD students in both directions, and that we really work collaboratively with you. And of course, it's our hope that the University of Maine will hire a lot of AI faculty to collaborate with us in these new initiatives. And in particular, we're really excited about applied AI for the Earth and climate initiatives that you're so well known for. Thank you.
Thank you, Carla. So we like to open the panel for questions. If the panelists would please start their videos again and unmute their microphones, I'd appreciate it. We have a question right now on online. This one from Arthur Fink and from Portland. The question is stated, granted that AI can be useful and powerful, but how does it earn the name intelligence, as in artificial intelligence? And does that naming invite unneeded fear and concern? I'll give this question first to our guest, our honored guest, Carla Bradley.
I was actually going to say I thought Roy should answer that question better than I. So Roy, I'm passing it to you.
Well, thank you, Carla. First of all, I'm sorry about the slides. I didn't notice they weren't moving. It's called intelligence, I think originally maybe with a little bit of hyperbole, like the digital brains back in the 40s when people talk about computers. But the term was coined because we hope to do some things that seem to require intelligence when people do them. As I mentioned, things like medical diagnosis or protein folding and things like that. So some folks, yes, are working on full-fledged trying to create intelligent machines, but not many. Most of us are concerned with adding intelligence to the computers. But I do understand your concern about unneeded fear and concern. That certainly is part and parcel of AI, has been since the beginning. But I think we're beginning to earn at least a little bit of the sobriquet of intelligence in some of the algorithms we're using now.
Ilya, so I'm going to mispronounce the question, or the person asking the question, but Ilya, and I'm not going to try the last name, has asked, how can current UMaine students get involved with UMaine AI, and in particular, Salome, the Second Lab?
Thanks. I think this question is for me then. So it's very easy. Just email me, and I try to do my best, and I usually don't miss my emails. So I'll get back to you as soon as possible. Just email me if you are interested, and then we take from there for sure.
I think this question is also for Salome, but I'll invite, after her, invite the other panelists to respond. This question from Lois Ann Kuntz: how is AI being applied to our current pandemic? And I refer this one to you, Salome, partly because one of your slides mentioned COVID on it.
Yeah, so with my ML team, we actually put together a team here at the University of Maine, and we started to see what are out there and some valid AI and especially deep learning techniques that we could apply here in this type of pandemics. There are some non-machine learning techniques that many people from very well-known universities are working on them, including Sears, and we started also from those techniques, but in specific, we are trying to implement recurrent neural networks, deep learning architectures to implement on this type of time series data. Of course, it's very challenging, and we have challenges, but we have also very interesting results. So this is very ongoing process, and hopefully the result will be out very soon.
Thank you. Anybody else?
If not, I believe there's some work. Oops, I'm sorry, Terry.
No, go
I
ahead.
believe there's some work being done elsewhere, as Salome indicated, on looking at finding drugs for treatment of corona, also some antibodies that might fit the virus. A lot of work's being done on that in general, and I think people are applying that to the COVID.
A question also from the internet. I'll start this one with you, Roy, but perhaps the other panelists can address it if you wish to pass it off. Can you address the issue of bias in AI, coming from the fact that people make algorithms and each person has their own biases?
I'll quickly address this and pass it to Carla because she's got way broader experience in this than I, not in bias, but in AI. One of the things we've, with the old style AI or the traditional AI, yes, the algorithms do have a bit of bias in them. I mean, everything does, but it's not, most of the things we're doing is not something that would be biased one way or another. We're coming up with general techniques. Some of the newer things, and Salome could also address this, that they're not biased so much in their algorithms as much as they are in the data that gets fed to the algorithms. Well-known problem with Microsoft's online chatbot that became anti-Semitic because people were feeding it data from the web that was anti-Semitic. So I'm not sure the best answer to address that, but I'm sure Carla knows.
Yeah, I actually, Roy, I was trying to think about how I could add to that because I thought it was an excellent answer. The problem is not the algorithm. The problem is the data. And data has two problems with it. The first is, what are the features that you use to define each data point? And if you don't have features that are able to fully represent your data, and a quick example of this would be, if you're trying to predict who has heart disease and all you have is age and hand size, you will correctly predict that older people with large hands will die of heart disease and younger people with small hands won't, but that's not what you're looking for. And if you don't have a good representative sample of the data, you might not even be able to do that. So it's the features that represent each data point, and then it's also the data points that you collect. A classic example of this is sentencing software that was used to predict recidivism rate, that predicted that African Americans should not be paroled because they were just going to recommit crimes. And that was based on data that was completely, the distribution was completely off because of who's incarcerated in this country. So these types of issues, they now have their own conference. It's very important. The first principle of applying machine learning is that you have a representative data set from which to train your models that is the same as which you will apply your models. And if it's biased in some way in making those decisions, and what was particularly egregious about the example that I gave is that the company that created this algorithm didn't explain why it was making these decisions. So just using machine learning as a box that you can't see into is a mistake, and that research also needs to happen on the explainability of the decisions that you're making.
I think we have another question, but I think we're going to have to push on. I have one question for our distinguished guest from Northeastern University. In the time that we have remaining, coming from the outside in particular, what are we've already mentioned the RU Institute is a new resource in Portland. We obviously have faculty and laboratories here at the University of Maine. You mentioned some of our other work, and you're particularly interested in applied AI. I'm curious, what are the resources needed to expand Maine's participation in research and development in this area? We appear to have a good start. What more is needed? So were I to analyze this, there's so many different areas of AI, which Roy did such a good job elucidating, and obviously you've made a really spectacular recent hire. What I would do if I was thinking about this was look at all of the areas, the research areas where you think AI could be applied to see, do you need computer vision researchers? Do you need machine learning researchers? Do you need natural language understanding? My guess is that your #1 priority will be machine learning, because even
because machine learning can be applied to computer vision problems, but I would do an analysis to see where do you really need the most collaborators, and then go after those areas first, because you'll be able to write the joint grant proposals and also interface with industry. And of course, I can say from just, well, not quite done with hiring season, still fighting really hard to get a couple more people. It's an interesting hiring year, I have to say. Machine learning people are really, really, really hard to hire. But a lot of people who are hired into industry are working on how to better serve you ads, and kind of we're sick of this as a field. So the fact that you have these built-in collaborations will really help you with your recruiting, because if you were recruiting me, if I was still research active and not an administrator, I would be extremely excited if on my interview, I could meet with the people that I would be collaborating with in these really critical and important domains that are particularly germane in terms of global warming.
All right. Thank you very much. We are running out of time in our panel, and we do need some time to transition to the next panel. Thank you to the panelists, to Dr. Turner first, of course, Dr. Yaseseke, and of course to our honored guest, Carla Bradley.
Thank you for having me. Bye-bye.
Our next panel is being led by Ali Abedi. Ali is going to be running a panel on the applications of AI in business, industry, and government, healthcare, and environment, which is quite a mouthful. For the other questions that were asked online, I'll do my best to answer them or pass them off to my panelists. Thank you very much. Ali?
Thank you, Terry, for running the first panel. I would like to tell to our attendees that if you like this first panel, we have 3 more for you to go, so stay around and we'll continue with the next one. So the application of AI in business, industry, government, healthcare, environment is the next panel. I will start off with a few examples of some of the research that we have been doing at UMaine, starting from space applications. In the past 6 to 7 years, through multiple different projects funded by NASA, we flew the first artificial intelligence software to International Space Station. All hardware was built by University of Maine students. They were all tested by NASA and flight certified by Boeing. We launched this to space to find tiny leak locations inside International Space Station by listening to the ultrasonic sounds. 1 postdoc, 2 PhD students, 2 master students, several publication invention disclosure came out of this. So the point I want to make here is that solving problems is one part of the AI work that we're doing here, but the most important mission at the University of Maine is to actually educate the workforce and educate the students for the next phase. So looking at the next slide, we look at the healthcare applications. University of Maine, in collaboration with a startup company, a spin-off out of UMaine, Activus Diagnostics, and Northern Light Health, one of the largest healthcare systems in Maine, have been working on using artificial intelligence for detecting Alzheimer's disease and related dementias. So recently, after almost a decade of prototype development, the past 2 years, we have had the National Institute of Health contract. We tested 100 patients with mild cognitive impairment, pre-Alzheimer, and maybe a little bit deeper into Alzheimer's disease with wireless sensors embedded into their mattress pad. So it was a home care sort of technology that was being tested on 100 patients, trained the system by physicians at Northern Light Hospital. And we were very excited to see over 95% accuracy when the AI can detect things in your sleep pattern that relates to Alzheimer's disease. Next slide is an application of AI in environmental scenarios. This is a new project funded last year. In the next 3 to 4 years, we're going to build and instrument the forest ecosystem with different kind of sensors for measuring soil moisture, measuring snow depth, measuring carbon cycle and all that. And the AI here will help us in 2 different ways throughout the year to be able to actually create wireless sensor networks that can operates throughout the entire year, not just for a few months because of the inefficiency in the wireless channel. We also provide this data to the foresters for monitoring the forest ecosystem. This is a National Science Foundation project in collaboration with the School of Forest Resources, University of New Hampshire, and University of Vermont. And the next slide basically talks about business and industry application. We are working with a Maine-based industry company called LDE Electronics that has one of the largest contracts with quick service restaurants, and we are trying to help them with building multi-type sensor networks that they can detect with much higher accuracy than current systems, the cars and different kind of trailers and cars coming in the drive-through of different restaurants. And we're going to apply the same methodology for automobile detection for self-driving cars, etc. So I don't want to take too much time. I just want to kind of give you some overview of things that are going on at UMaine in the past decade or so of applied AI in electrical and computer engineering department. And without further ado, I would like to pass the mic to our first panelist, Dr. Kay Aiken, co-founder and CEO of Introspective Systems, to talk about her exciting research. Kay, take it away.
I don't think my video is on yet. By the way, Ali, thank you for the promotion, but I am one of the few non-PhDs here. I have a Bachelor's of Engineering in Energy Systems. So I'm going to do a really quick summarization of research that was mostly funded by the Department of Energy, but also a foundation in Israel called the Berg Foundation, which is a joint collaboration between US companies and Israeli companies. Next slide. So a lot of talk has been about most of this world wanting to get to renewable energy. Maine now has an initiative by Governor Mills to by 2045 to be 100% renewable. And that's just not 100% renewable in the, my video is apparently not working, thank you, is 100% renewable across the entire energy use. So that is including the electrical system, transportation, process heat, and space heating for our homes and businesses. This is actually making the electrical infrastructure very, very complex. And one of the ways we can solve this problem is using artificial intelligence. The work we're doing with the Department of Energy is to design a new architecture that can be rolled out in the entire United States. The advantages to it is if you try to do a centralized system, you would end up with so many separate agents, so many individual nodes that you would have to control that the computing power required would be astronomical and would be unable to solve the problem. So we've actually building an architecture using artificial intelligence to split the grid up into many, many small cases. So you can think of one small area would be your house, and then the next area would be your neighborhood, and the next area would be from your substation down, and then it would be a part of the state, and then the entire state. And this is actually how ecosystems work. Ecosystems are all autonomous individual agents that work together to solve a global optimization problem, and that is living. So the idea is biomimetic. It requires distributed intelligence, and in this case, distributed AI has aspects of being adaptive, just like an ecosystem, and is also fractal, in other words, multiple layers. Next slide. So the biggest problem in this area is how do you coordinate the control? How do you not have runaway conditions working across the entire system? Some people might remember the 2003 blackout in New York City over most of the Northeast, where a single one error caused a blackout over 10 or 12 states. So what we've done is actually brought two areas together, control theory and economics, into one type of algorithm that is able to use market-based constructs, market-based economics to actually manage the flow of energy. This idea uses the sub-optimization of breaking the electrical grid up into multiple layers, and then pricing gateways that actually price power at the local area based upon the scarcity or amount of power that's available. Next slide. A very quick review. Some of the control theory people will recognize this. This is actually called the Bellman equation. This is a subset of that using the idea of adaptive dynamic programming, which was formed early in the 1980s. Our particular special sauce is we have both online and offline learning that are continuing to learn and evolve on the grid as they're working. This class of algorithms are very, very good at solving multidimensional problems that are up till now have been unable to be solved. One of them is a prime idea that a lot of the AI researchers have talked about is the traveling salesman problem of having 100 places to stop at and finding out what the quickest route is to do that as quickly as possible. This is actually a very, very hard problem to solve, and these classes of algorithms have worked on solving those. This form of ADP allows the consistency, allows the system to evolve as needed as time progresses. Next slide. This is actually a real world example of the research. Some of you might have heard about a microgrid being developed on the Isle of Idaho. And in that case, where we're using a 300 kilowatt solar array, a 1 megawatt hour storage facility, a battery, as well as over 20 heat pumps that actually help balance the grid. And what is driving the decision making for those devices is actually a price signal. And that price signal prices power in real time using AI to try to balance the system so there's enough power at all times. So when power is scarce, consumption will go down, heat pumps will start turning off, and production will go up. In other words, the battery will provide more power. And when power is abundant, consumption will go up, basically shifting the power use to a different time, and production will go down. So I'll have that, and we'll go with the questions.
Thank you very much, Kay, for presenting this slide. So let's move on to the next presenter. Dr. Sepide Ganabati is Assistant Professor at the School of Computing and Information Sciences at UMaine. Sepide, please.
Hi, we have a privacy engineering regulatory compliance lab, Percy Lab at UMaine, that we deal with different aspects of protecting privacy of individuals at the age of AI. We deal with basically making sure that the applications, they don't collect and use or process personal information without the user's consent. Next slide. So one of the advancement of AI is that like mobile applications, they collect lots of massive amount of information from the users and they process those data. And lots of times they might violate privacy of individuals. And for example, they might record the audio without your permission, or they might, for example, collect the collection location without like you even know it. And what we are doing at Percy Lab, we try to solve like these problems of protecting personal information, even though the applications use and process those information for their purposes. Next slide. However, protecting personal information is not easy. One of the factors is that governments impose laws on developers that they need to give notices to the individuals that what are they collecting, what they're doing, and how their applications are using these data. To create these type of notices, you need a lot of efforts because first of all, you need to have some legal backgrounds, and getting legal experts are very expensive. The applications, they constantly updated. The laws are also getting updated. And it's not very easy for developers to match their application behavior with what actually they give notice to the user. And in Percy Lab, we try to resolve these problems by developing some frameworks that basically tries to, instead of just like writing privacy notices, tries to translate directly what happens in the applications into natural language statements related to privacy. So instead of that, developers use some privacy generators that they just create inconsistent and generic application, we try to resolve this problem. Next slide, please. And one of the projects that we have is basically developing a recommender system that goes from the code segments of the applications into some statements like what you see on this slide, just very simple statements that the users and the developers, they will understand. Next slide, please. And as I said, for this, we are using the AI techniques, and we are also protecting the data. So the advancement of AI, we're still protecting the user so that they have both of the balance between getting benefit from the techniques that AI offers and also protecting their individual privacy. Next slide. So we have like several projects, like one of them is related to Android application. We are also dealing with Internet of Things and blockchain to protect the individual's privacy in healthcare, in smart home environments, and we are also looking at the regulations to make sure that these privacy statements are also compliant with the regulations. And we have 4 phases for this project, and several of our PhD students and undergraduate students are dealing with this project. Next slide. So the main contributor at the moment of the project are the senior privacy research scientists from Google. We have 2 PhD students involved in the project, and several undergraduates are also working to develop such application to protect individuals' privacy. Thank you.
Thank you very much, Abedi. So next panelist is Dr. Tim Liu, Harold Alfond, Associate Professor of Business Analytics from Maine Business School. Tim?
Thank you, Ali. I would like to add some comments on this important topic from the business perspective in 2 different aspects. One is business application of AI, and the other one is a philosophy of using AI in business. So first, at the application side, we can classify, in a general sense, all AI business applications into 3 categories, and each serves a specific objective. So first is a rule-based machine learning to support high-level business decision-making using transparent and accessible algorithms like regression or tree-based algorithms that require significant human intervention. So here, it is very important to point out that the rule refers to business rules, not any mathematical rule. And secondly, we have a purely data-driven machine learning to efficientize low-level business process using neural networks or deep neural networks based algorithm that depends less or little human intervention. And the third is the automation to optimize business operation and production by replacing human labor with robotics. I believe the most recent example is automation in meat processing. And at the philosophy side, I believe the fundamental reason that AI technologies are playing and will play much more enhanced roles in business is because we are in the so-called 3rd AI wave. The key feature of the 3rd AI wave is that it is powered by high performance computing infrastructure, and big data. So because business is actually all about human behavior, which is probably the most important lesson we learn from the COVID-19 pandemic. So in business environment, it is not really about artificial intelligence at all. It is really about collective intelligence of human and machine. So for example, human is better at thinking and perceiving, and machine is better at predicting and recognizing. So there are two key questions for anyone who wants to introduce AI technology into their business. One is, what work should machine do, and what work should a human do? So the other question is how to optimally integrate the human work with the machine work together. So it is widely agreed in business researcher community conceptually to serve the three different types of applications of AI in business. AI can play the role of tool, assistant, peer, and manager. So essentially, what we really want in business is a bidirectional relationship between human and machine, so that machine can better support or manage human work, and human can make machine work better. So that is all for me today. Back to Ali. Thank you.
Thank you very much, Tim. Our next speaker is Dr. Arup Ganguly from Northeastern University, Engineering and Computer Science. Arup?
Thank you very much. I think my video needs to be started from the host site, Thielen. Okay, thank you. All right, so once again, thank you for this opportunity. I am at Northeastern University, where I lead the Sustainability and Data Sciences Laboratory. I'll talk a little bit about what research we do there. In terms of this particular panel, one of my former PhD students has started this climate risk analytics company, which focuses on climate change adaptation through data analytics and AI, especially in the urban sector. This started as an NSF SBIR project, and then now it has been embedded within one large exchange. So with that, if you could move to the next slide, please. Thank you very much. So yes, thank you very much. So the case I'm trying to make here is that when you think about climate, when you think about the science of climate and the adaptation and the implications, we are talking about inherently coupled complex systems. So here is just one example from the country where I was born and grew up in, which is India, where there's a lot of dependence on the monsoon. So in 2012, there was delayed monsoon and extreme heat waves, which together caused a surge in agricultural water demand. And because of various policies that have been put in place with all good intentions, but then the way they sometimes work, they have unintended consequences. So there's an extreme surge in agricultural water demand, as well as electric pumps that were put in place. And that led to increased stress on the power grid. And what that caused is the 2012 India blackouts, which is the largest blackout ever in terms of population impacted. And that in turn, because of the way the power system impacts railways, that in turn, or signals and systems, that in turn impacted one of the major lifelines of India, which is the railway network. So right here we have going from the natural system of climate and weather and monsoon, and connecting with both policy and human behavioral issues in terms of surge in agricultural water demand, use of electricity, and then going to engineered systems, basically power grid and railway networks. So just shows how interconnected we are when we think about climate and adaptation. If we go to the next slide, please. So the kind of work we have been doing then is on the climate side, use of machine learning for weather extremes, and on the engineering and infrastructure side, the impact side, looking at critical urban lifelines, interconnected critical urban lifelines. The one common theme is what some people have called domain-aware machine intelligence. So in the climate side with complex spatiotemporal systems, we have been looking at physics-guided machine learning. And with critical infrastructure side, we have been looking at network science and engineering, which are informed by novel insights and principles from engineering and policy. So broadly, the theme here is machine intelligence, but which are domain aware. If we can go to the next slide, please. So one work that we have also done is, we have been working with the city of Boston, Climate Ready Boston report, the last version. Some of the my PhD students right now are working with the next version of that report. We have worked with the town of Brookline, Mass, in dealing with public health impacts of urban heat waves, looking at risk, exposure, vulnerability, as well as looking at adaptation and mitigation aspects. Next slide, please. And we have also looked at climate risk in urban areas with, for example, looking at sea level rise and what that means in terms of urban floods, and then connecting that with assets at risk, and looking at recovery models with network science, such as after Sandy in New York City, how did the New York City MTA, the mass transit, recover, and what could have been done in terms of systematic recovery principles. This was an article that we published in Climate 2020. It's the United Nations Association report. If we go to the next slide, please. These are all the students and postdocs who have helped in many of these efforts. Thank you very much. Ali, over to you.
Thank you very much, Arup. So at this point, we'll open it up for questions. So I would like to ask all the panelists in this panel to turn on your videos and unmute yourself. And I'm going to go over the Q&A service to see what kind of questions we have. So the first question that is coming from Carissa from University of Maine. She's asking that what sort of resources will be available moving forward for labs that want to apply neural networks. I can answer this question. There is a plan to basically have a series of seminars related to different aspects of the AI and machine learning and application and theory side that we talked about today in the fall. So we'll get much more deeper into these in future. And I would also recommend to reach out to any of our panelists in this webinar to start forming collaborations like that. So I'm going down the list for the question. I have a question for Kay. How does decentralizing the grid affect susceptibility to cyber attacks or natural disasters? Kay?
That's a good question. So one of the innovations that we're doing with our the term we use is transactive energy, which is the idea of using economic systems to manage the grid. In our case, the system is naturally cyber secure, not only because it's fractal, where it's called encapsulation in the computer industry, where you can actually isolate parts of the grid from the other parts, but also in our particular algorithms, we strictly use a downward facing pricing signal. So a price is sent from an upper node to a lower node, and all it does is say, right now the price of power is 12 cents a kilowatt. There is no upward communication, so that makes the system very, very secure. It does make it a little more fragile. In other words, if you do have cascading, it can propagate, but the idea of fractalizing the grid mitigates that problem. So it's an idea of rewards versus penalties, and you try to balance that.
Thank you very much, Kay. So next question is from Eileen from Maine Geospatial Institute. So the question is that what are some other methods being used to build Maine's resource network to help us all tap into available expertise for shared projects and programs. So anybody want to take that? So I will try to kind of briefly answer this, at least from University of Maine Orono point. We have created UMaine AI initiative. So we have a website that basically lists all the faculty who are involved in this research, all different projects, and we'll definitely be happy to serve as a hub for this. And of course, there is, I think, a lot of activity also happening at the Maine Business School that Dr. Liu also mentioned. And I think, Tim, can you also comment on how your business sort of connections with the Maine businesses can help people get connected to the network?
So actually currently in our Maine Business School, we have recently added one new concentration in business analyticals into our MBA program. And we are also in the process of proposing a new Master of Science program in business analyticals. And we are also actually closely working with a couple of local business in Maine to build the two programs. For example, I have been working with ILB and the Bangalore Savings Bank to provide opportunities for current and future students like internship and or some real business projects provided by these two companies. So we will have a lot more to do in future.
Thank you very much. So we are out of time. I just want to mention that those questions which do not get answered during this live session, we'll provide answers on our AI Initiative website, along with the videos and slides of these presentations. So I would like to now thank all the panelists in this panel and hand off to the next panel moderator, Dr. Penny Renegans, Director of School of Computing and Information Sciences at University of Maine. Penny.
Thank you, Ali. In this next segment, we'll turn to the needs and resources for education and workforce development to support the growth in AI capabilities. I'm Penny Renegans. I'm Director of the School of Computing and Information Sciences here at UMaine. I'm pleased to be joined by Jason Judd, Director of Educate Maine, Sharmila Mukhopadhyay, Director of the UMaine Frontier Institute for Research in Sensor Technology, and Walter Rahl, President of the IEEE Maine section. We'll each give a short statement, and then we've left plenty of time for answer your questions at the end. So please use the Q&A box to send us your questions. Jason will lead off with some thoughts about K-12 education.
Great, thanks, Penny. Great, hopefully everybody can see my slides now, and we'll go ahead and get started. I'm excited to be here. I've already learned a lot about from this conversation so far, and I was asked to talk about what's happening in K-12 education as it relates to artificial intelligence. As Penny mentioned, I'm the Executive Director of Educate Maine, and Educate Maine is a business-led education advocacy organization, which is focused on increasing education attainment and career readiness. We facilitate a program called Project Login, which is really about building Maine's tech workforce, working with K-12 schools, higher education institutions, as well as employers. So we like to kind of work with everybody who's supporting this work, moving forward. So what I wanted to do is give you a sense of what's happening with artificial intelligence right now in Maine and what the K-12 system looks like. So I wanted to pull together this nice graphic, which really describes the 5 big ideas in K-12 education as it relates to artificial intelligence, because I think you can naturally kind of think about, what are some of those building blocks in addition to sort of a strong math and science foundation and computer science foundation, where students are beginning to learn what AI is and teachers are beginning to learn what AI is and learning some of those skills. And you can see that some of the skill and knowledge you can certainly learn in computer science classes, but you can also learn in classes like, social sciences and engineering and science and math, etc. I wanted to talk a little bit more about computer science education here in Maine, to just remind folks of kind of what the climate looks like. In Maine, about 40% of our schools have computer science offerings. And certainly that's a number that we're trying to increase collectively, so that all Maine students have computer science instruction in the K-12 system, so that they can get excited about potential majors that relate to this area in the higher ed system. So there's a number of different initiatives happening. One is the CS for Maine Coalition, which is a whole group of organizations working together on policy as well as on teacher professional development to get computer science into more schools and to help train more teachers on how to teach computer science. The Department of Education here in Maine has also worked on a computer science education state plan that really maps out what the next couple of years needs to look like for Maine to continue to scale up computer science activities. And then we have a number of active teacher professional development programs, some through the universities, some through nonprofits, that are teaching teachers that are brand new to computer science how to be computer science teachers. And certainly a lot of that different curriculum has not only building blocks that connects to artificial intelligence, but specific lessons that students can do to explore this particular topic. Also, our code activities and other sort of short-term lessons are one way for students and educators to learn what artificial intelligence is all about and how it connects to the work they're doing in K-12 schools. Broadly, we have more work we need to do in this area to make sure that our young people have a good understanding of AI and computer science before they get to the higher education system. So I also wanted to talk really briefly about something that's in common with both the K-12 system and the higher education system, which is a reliance on internships and experiential learning activities. We want to make sure that young people can explore these skills directly with employers in addition to in the classroom. We run a program called the Focus Maine Intern Experience with more than 600 interns that come to us during the summertime. And we're the convening organization for them. And many of those students are in computer science related internships in Maine. And what we hear from employers is the more experience, knowledge, and interest young people have in artificial intelligence, the more marketable they are to getting those competitive internships. So among our employer community that we work closely with, there's certainly interest in the expansion of these experiential learning opportunities, both as students finish high school, as well as move ahead to their college experience as well. So I couldn't present without really emphasizing partnerships, which is, this particular presentation this afternoon, I think, is a good illustration of kind of leveraging a lot of different folks with different expertise from all perspectives, and making sure that we can really all work together on this particular topic. So there's a couple of good things I want to share, which is one, simply information sharing is really essential. Connecting formal partnerships with both K-12, the higher ed institutions, as well as the employers. Working together on teacher professional development and using sort of joint assets and expertise to be able to leverage these opportunities and apply for particular grants together, as well as really convening, hopefully in person in the future. The Computer Science Teachers Association will be coming to USM in October for all of New England. So that's a great opportunity for us to do some work together and do some conference sessions where we're able to put a spotlight on what's happening here in Maine, as well as collaborate with our New England peers. And with that, I'll turn it back to Penny.
Thank you, Jason. And I'm hoping our hosts will turn my video back on. Thank you. So building on the foundation of what Jason's talked about, I want to move on, talk a little bit about how we can follow up on that foundation in higher education. Okay. At the undergraduate level, Cultivation of AI skills and expertise are really part of a broader base that must include courses in program design and development, statistical foundations, electives in AI and supporting technologies, and applications to real problems needing AI solutions. The UMaine program, undergraduate program, sort of best embodying that is the Bachelor of Science in Computer Science. This ABET accredited program provides a foundation in that program, design and development, in system fundamentals, mathematical foundations, and ethics. And it culminates in a 2-semester capstone that emphasizes professional practice and the skills that students will need to survive or to excel in the workforce. It also offers electives in AI-related areas like AI, machine learning, computer vision, cloud computing, and privacy. Alternatively, students can enhance a major in pretty much anything with a minor in either computer science or statistics. Graduate programs offer a greater opportunity to specialize and to develop AI skills and expertise. 3 UMaine degree programs have substantial AI content. The first are the master's and PhD programs in computer science, which help develop the background needed to innovate in AI technology and applications. A cluster of master's, PhD, and certificate programs in the spatial informatics area allow students from a wide range of backgrounds to develop the ability to apply this new technology to analyze spatial data. And finally, the Maine MBA offers a new concentration in business analytics that Tim just mentioned that trains students in the processing and analyzing large-scale business data to extract valuable information and then discover meaningful business knowledge to recommend optimal business decisions. Additionally, many UMaine graduate programs in other disciplinary areas offer specialized courses or course topics or project opportunities that apply AI tools to challenges in that field. These disciplines range from math and science to engineering to the social sciences. Okay. 3 new programs under development will offer even more opportunities for students who wish to acquire the background needed to join the AI workforce in the future. A proposed minor in business information systems will bring business analytics to the undergraduate level. A proposed Master of Science that Tim mentioned in business analytics from the Maine Business School will increase graduate opportunities in this area. And finally, a cluster of proposed graduate programs in data science and engineering will be accessible to students from a wide variety of backgrounds. These programs build on foundations in program development, statistics, and systems, and address themes in data collection techniques, data representation and management, data analytics, including AI, data visualization and human-centered computing, data security, preservation, and reuse. The initial application area domain specializations will include spatial informatics, bioinformatics and biomedicine, business information, social and behavioral data science, and engineering analytics. And with that, I'll hand the floor to Sharmila, who will talk about AI workforce development.
Thank you, Penny. Let me share my slides. Hopefully you can see my slides. What I will talk about are a few areas related to workforce development. And I'm from the Frontier Institute of Research in Sensor Technologies. So I'll talk a little bit about understanding the broader ecosystem for AI and stay with one application example, which is on everybody's mind right now, is pandemic response, and make a few comments about the educational workforce. So if we think of the broader AI ecosystem, a lot of times what we are thinking of is there is an application area, which could be anything, which AI is going to be applied to. And the ones I've marked in red are the ones I see very pertinent to UMaine. And then you have sensors or other data collection kind of agencies, which is the perception function. You collect all that, and then you have the brain component of AI, which is like maybe layers of sensory learning and reasoning. And you did here a lot beyond simple algorithms. You have the machine learning and the deeper learnings. And then that creates some logistics of how to respond, maybe through another set of hardware components like robotics or actuators, etc., or decision-making, business decision-making to improve the application. So with that kind of a background, like I said, I'll stay with one example, one subset of all the application areas. One subset of healthcare is pandemic response. So if you look at where AI is helping in pandemic response, again, that's a huge area, helping right now and can help in future. Let me just stay with a few. One could be the testing. One would be drug and equipment, development. The other is contact tracing, supply chain, etc. And again, few topics are marked in red. These are the areas where I myself and some of my colleagues and Frontier Institute are involved in. And just to give you an understanding of what the workforce needs to understand, even within a given topic, the work could be at the research level. So this is like a bench research, work I would do in my lab is trying to compile or design a hardware component for sensing different aspects. And then AI would sort of help us maybe quicken this process and then go into some clinical level, downsize what's important, and then collect the data from that and provide the feedback loop. So this can happen in different specific applications. So based on these applications, I wanted to spend a little time on what would the workforce, AI workforce, what do we think would be useful to succeed? So just to give you an example, these might be two areas which we hear a lot, how AI is currently helping and can be improved for the pandemic response application. And the immediate need we see is that AI professionals need better understanding of the application. The application professionals also need to better understand the AI professionals, how they're thinking or what the algorithms can do, cannot do. So my suggestion is, and I think a lot of areas, it's important that we create application-specific modules within the education system, and those should be collaboratively developed by faculty from both sides. And then going forward, the mantra for effective education would be cross-disciplinary training. And there are several approaches for that, maybe AI-specific courses, co-mentored projects, student teams. So this is just an example I'm throwing out. Facial recognition is a known AI component. Fever detector is a known sensor technologies, depending on how simple to how complex that is. You can combine to have this disease surveillance kind of improvements in AI or future AI. And without taking much time, I wanted to end with one need I feel we need to instill among AI professionals is the critical thinking part, because they perhaps would be better than others to quickly evaluate the credibility of the information that is generated by or manipulated by machines. So that would be a very important component of the AI workforce. So with that, I would hand it over to Jason. Thank you.
Good afternoon, ladies and gentlemen. Thank you to the University of Maine for inviting me to participate in this presentation. My name is Walter Rall. I'm the chair of the IEEE Maine section. Recently, I've launched a small startup in the space of artificial intelligence and autonomous systems. And during the day, I work at General Dynamics Ordnance and Tactical Systems in Saco. And it provides a very unique opportunity for me to see this domain from an industry perspective. In the few minutes I have, I would like to chat a little bit about tangible economic impact of artificial intelligence and some specific pursuits I've been involved in. And then from a workforce pivot perspective, I wanted to talk about two things. First, the domain of available resources for an existing workforce that is interested in pivoting. And then secondly, to investigate some fundamental ideas around what research and development AI workforce needs to be equipped with. So to talk about the economic opportunities, I've recently been involved in some solicitations from the U.S. Navy. There are two that I wanted to highlight here. The first one is around naval depot modernization and sustainment. The U.S. Navy, of course, has got billions of dollars tied up in sustainment activities. Most importantly is logistics and maintenance around condition-based maintenance, prognostics and health management, et cetera. And the slide top left sort of indicates the application of artificial intelligence to that domain. But more importantly, for those who are involved with possibly BIW or activities associated with the marine industry in Maine, the photo on the right is a screen capture of a Trident nuclear submarine missile. And recently the US Navy launched a solicitation looking for machine learning based data analytics for the autonomous navigation of these. To give you an idea of the economic impact, the US Navy is #1 in its pursuit these days, has indicated the Columbia-class submarine as the highest priority development to replace the Ohio-class submarine that serves as the platform for the Trident. The Columbia-class submarine will cost $30 billion per copy, and that certainly is a sizable sum by anyone's imagination. Each Trident missile is worth $30 million, and of course, a significant investment in the nation's national security is first and foremost today. So, workforce education. I like to differentiate workforce education along two domains. First of all, we have those that are interested in AI applications. And I would like to posit the idea that there are significant resources available for any possibly mature or even somebody out of school for a few years who has been involved in some other line of work and who wishes to pivot into the artificial intelligence / machine learning workflow. People like Andrew Ng, Sebastian Thrum, Lex Friedman and others from Stanford and MIT, for example, and those who are involved at Google, Google Mind, Google Brain, they've all provided excellent resources, TensorFlow, PyTorch, Deep Learning at MIT.edu, and intro to deeplearning.com from MIT are all excellent resources. There are what we might call some renegades at Fast AI and OpenAI that all have excellent training materials available. These are all free of charge. You can actually execute code snippets using Google Code Lab under the tutorials available from TensorFlow. And I just would encourage everybody to think about applying to some of these opportunities. Finally, in the area of workforce education for artificial intelligence.
Thank you, Walter. We're going to have to, if you want to take any questions, I think we're going to save that.
Oh,
Sorry
sure.
to interrupt.
That's fine. Thank you very much.
If all of the panelists could now turn their videos and their sounds back on, we'll take some questions from the Q&A. So if you have a question, be sure to type it in. The first I'm actually going to read briefly and then pitch to the next panel. And this is asking in parallel to technical advances in computer science education, what's being done to explore some of the ethical aspects, which is the whole next panel, so stay tuned for that. The next one I think makes sense for Sharmila, and this is what AI approaches have been used in healthcare diagnoses.
There are quite a few of the AI community. I think I could see some in the slides. It's like a huge, big area where, for instance, even trying for the drug development, let's say, you're looking at the entire data you have available for the genomic sequence, and then trying to piece from that what would be the best, best sort of sequence for a given. For instance, even within, if you look at SARS, there's an entire data set on the different COVID viruses and how the sequences work out. And a big area is trying to model from that And AI is helping with that, is trying to model and come up with the best protein, even for developing the sensors, which would be the best antibody, which can give you the best detection without confusion and specific kind of a system. So those are all where our AI colleagues are helping us. And I'm sure you can come up with many more of those. I can see Walter's light on, so I don't know if he's, if you have more to add, but this is a huge area actually. And we are in the process of trying to even see, for instance, even to get a signal, you can get 10 different kinds of signal. How do you sort it down on which is the best signal to use on the field or remotely, monitor and things like that.
Thank you, Sharmila. This one's for Jason. What are the biggest challenges for K-12 education to be able to prepare students for AI futures?
I think the biggest challenges certainly are there are a couple. One is resources and making sure that with such a large state with so many different districts and local control, availability to scale up teacher professional development and develop kind of long-term high quality teacher pipelines for computer science instruction. And then certainly I think we're still figuring out where computer science in K-12 kind of fits into the school day in terms of time and what their priority looks like, and when it's appropriate to integrate into other courses and when it's appropriate for standalone offerings. But the good news is we're making some really good progress, working really collaboratively with partners, and I think we're going to get there over the next couple of years.
Thank you. Walter, can you say something about what auxiliary skill sets are required to support AI development?
So in addition to basic machine learning and the core computer science stuff, data is huge for artificial intelligence. Data science practitioners, I think, are very important. Data gathering and then associated activities, instrumentation. Hardware engineers are very important in many of these domains. So good electrical engineers are terrific for artificial intelligence.
Not that there's any bias in that opinion.
No, not at all, not at all.
Thank you. Sharmila, can you, let's turn it inside out. Can you say something about how AI might influence the field of education?
Oh, actually, AI, I think, is going to change how we teach, right? It's going to change the classrooms, make them a combination of maybe virtual and in-person classrooms. So there's a lot of augmented reality, which is already, especially in areas, let's say right now, even to look at these medical imaging guys, how they're looking at or building a 3D image of what they got from their MRI and stuff like that. So that is at a higher level. Even at a lower level, maybe in K through 12, I can see a lot of augmented reality coming into the classrooms. So the teachers need to really also be retrained, I think, and we are constantly learning every day, is how to create firstly the optimum mix of in-person hands-on versus virtual reality, and how to help the students understand them. And then also the other part, which is very important for the classroom, AI in the classroom, I feel, is that, sometimes the high achieving students can get a lot and they could be moving in their direction. And then sometimes the students who were falling behind might be going in the wrong direction. So which we are learning as we are offering classes virtually right now, is it's a slightly different aptitude needed in the teachers a little bit to stay in par with different students going different directions. And I think AI will just keep increasing that.
Thank you. Jason, can you maybe expand on that a little bit and say something more about what K-12 teachers can do now to sort of support their students and that developing the interest and background that those students are going to need to advance AI innovation?
Yeah, I'd be happy to. I mean, to be honest, sessions like this afternoon where teachers are learning about all this wonderful work that's happening, that's on the cutting edge in terms of research and actually addressing, COVID-19 and healthcare and those types of things. I think educators simply can engage in some of these conversations. K-12 educators can engage in some of these conversations, talking to experts, talking to researchers. I think that's really helpful so that they can talk to their students about these are career possibilities. The other thing that we're working on really hard is just bringing K-12 educators and higher ed institution, faculty, and employers together in the same spaces to have these conversations, to think about local partnerships where they can work together on projects 12 that connects to what they might be learning in an undergrad program. So whole variety of options, but I think it just starts with partnership and engagement and asking questions and learning more.
Thank you so much. I wish we had more time, but that's all we have. I'm so grateful to these people for sharing their expertise with us. I'd like to thank them for taking part in this panel. And I'd like to pass the floor to Charlene Jane, who will lead the next panel on issues of ethics and society.
Thank you.
Thank you.
Penny.
Thank you, Penny.
Good afternoon. I'm Charlene Jane, and I'm a professor in civil and environmental engineering. And one of the big questions, let's see if this works. One of the big questions in the realm of AI work is how to deploy AI in an ethical, safe, and fair manner. And this is important at all levels, private citizens, communities, industry, and governments. So for the next half hour, let's focus on these issues at the intersection of technology and society. And we have essentially four interlinked facets here: social, ethical, policy, and legal. And so we have with us today Jim Isaac, who's an electrical engineer and a past president of IEEE Computer Society, a visionary in the field of AI. Jim writes extensively on the future of society, one powered by AI. And we have Harlan Onstrud, who's an engineer and a lawyer and a professor of spatial informatics at UMaine. He's the past chair of the U.S. National Committee on Data for Science and Technology of the National Research Council. And finally, we have Peter Guffin, who's a visiting professor of practice and co-director of Information Privacy Law program at the UMaine Law School. And he heads the privacy and data security practice at Pierce Atwood LLP. He has written extensively on cybersecurity law, information privacy, and has consulted and counseled on Wall Street. So, Jim?
Okay, I think we have some slides. Let me expand a little on aspects of this bio because they relate to some of the questions that have come up. Whoops, can you go back one? Thank you. The communications, IEEE USA is a part of IEEE that deals with federal policy. You need to go back one again. And that federal policy issues are things like privacy, cybersecurity, 5G rollout and technology, and so forth. So the topics that we're talking about here roll into that. I chair a committee on the actual applications of communications policy and computer policy and participate in the AI committee as well. I think Walter's also part of that activity. Another one of the areas I'm involved with is the IEEE standards work on AI ethics. And all these are hot links. So when you get the slides, you can actually go through in depth and see what kinds of documents are hiding behind this. There's a huge amount of documents on AI ethics. I've highlighted one here in the next slide on the AI persuasion or nudging policies. And then finally, I'm involved with the IEEE Collaboratech activity, where we have some communities that can maintain an ongoing dialogue on some of these topics. And again, those are open to the public. So if you're interested in some of the topics there, it includes privacy and trust as one topic. And another one that's just come up is broadband and COVID-19 and the experience for rural broadband with that. So those are the kinds of things we're working with there. So go to the next slide. Okay. Well, anyway, you'll have a chance to look at the slides as they become available online. One of the challenges you heard about earlier is the fact that a major aspect of AI application today is in advertising, and huge industries, Apple, Amazon, Google, Facebook, are all driven in part by advertising revenue. So that drive, driven with AI behind it, creates an opportunity to both maximize the effectiveness of AI at bringing forward customers and encouraging them to buy classic marketing advertising, but also influencing them. And one of the challenges we face with that influence is twofold. Certainly there are people out there who want to influence people independent of their actual best interests. So there can be abuse of that potentially in that way. And the second one is letting AIs loose to maximize a specific objective, whether it's the most people buying a certain deodorant or whether it's to vote for a certain candidate. One of the problems we have with AI, deep learning, particularly when it's built in with feedback loops, is it can determine how to best accomplish its objective in ways that the humans involved with it may not at all understand. One of the questions that popped up earlier was on AI bias and variations of that, but AIs in deep learning are capable of acquiring and applying approaches that the people who created them may not understand. So that leads to my, well, and I should add that AIs are not able to explain themselves. Sometimes people running them can, and sometimes you can back engineer, reverse engineer, and try and figure out why the AIs came up with those conclusions. But complex systems like this are not always easily reverse engineered, and it's not clear that AIs will ever be able to actually explain why they did something. I might add, humans aren't really good at that either. So as we move closer to human type intelligence, we shouldn't be surprised if the machines can't explain their decisions. The next slide basically focuses on where I see the biggest challenge we face. Abraham Lincoln is reputed to have said this. It isn't actually his quote, but we'll use it as his anyway. You can fool some of the people all the time and all the people some of the time, but you can't fool all the people all the time. I take that to be three assumptions. And if you apply AI to that, the real question is, can you fool a sufficient number of people a sufficient amount of the time? Which leads to this issue of AI-driven persuasion, nudging, propaganda, brainwashing. There are a variety of names for what it can be done there. And there are fairly good research results coming out about what AIs can derive about individuals in terms of their personality and various characteristics. My last slide, useful slide is the next one, might as well go to it. Points to a couple of the research people doing work on this. Mikhail Kosinski at Stanford is doing work on analytics and privacy and psychological analysis using AI technology and Facebook. So that's one reference point for that kind of research. There's also efforts, the school that Stanford had on persuasion using technology, that program is now closed down. However, I noticed Oxford has a similar program on the online persuasion technology. So this area is being something that's studied. We are starting to understand that it can be done and how it can be done, and the use of AI and applying to it. It is multidisciplinary. This is not something that the technologists understand. It's not something that psychologists understand. It requires that multiple disciplinary perspective and leads to some really challenging questions about whether AIs, not maliciously, not the Terminator type AI, but simply AIs trying to optimize a particular objective, will start to influence us in ways that go beyond our control or our awareness. So
thank you, Jim.
There, and we can go to the questions
Great.
that may arise. Thank you.
Thank you, Jim. Harlan?
Okay, well, as you've been hearing from most of the previous speakers, the positive societal applications of AI are myriad. Many of the applications, particularly those focused on advancing science, tend not to raise human privacy or human autonomy concerns, and indeed promise great benefits for humanity. Yet, many current deployments have already given rise to substantial negative societal effects. Most of us interact with AI-developed algorithms on a daily basis, yet most of us are unaware of those interactions, and most of us are unaware of their effects on our daily lives. Our legal system, combined with technological advancements, has made massive accumulation of data possible, as we've been hearing. By knowing your digital tracks in detail, AI techniques are better able to analyze your past action patterns and predict your future actions, as well as those of millions of other people and your interactions with those other people. Algorithmic operations applied to big data are being used to classify and target individuals to sell you goods and services more effectively and influence your decisions and attitudes in social and political contexts up to and including voting. Modern decision guidance systems are hurting us in our choices. These conditions have also made massive wealth concentrations possible. Slide 2. I'm not going to go into details, but AI has been a major factor in automated propagation of discrimination, has greatly facilitated the expansion of income inequality, will continue to be a growing contributor to massive job loss globally, and many of the negative effects of AI are a result of a US legal framework which is overly supportive of surveillance capitalism. Now, I would argue, of course, that capitalism is good, but not all capitalistic approaches are well suited to support justice in a democracy. Jason Lanier, the father of virtual reality, argues that there is more than one way to build an information society, and we in the US have chosen the self-destructive path. So let me just suffice it to say that AI advancements have been complicit in advancing serious, widespread, and substantial challenges for democracies. Slide through, the next slide. So how do we flip this around? How do we alter some of the applications of AI to convert their use to positive forces in improving societal conditions? And I think research is going to be a large part of the solution. And one fundamental question we are currently pursuing here in Maine is, how may information societies enable rich opportunities for all humans to more equitably share in the financial benefits of vibrant information economies, while also supporting the agency and autonomy of individual humans? That is, how can we bring ethics back into the equation? Slide 4. So a current research focus at the University of Maine is on the development and exploration of ethics-driven, market-based, combined legal technological models. Technology by itself is not the answer, but neither is merely tweaking the legal system. We need to explore a range of combined legal technological approaches and then deploy those models through proof of concept software development in order to illustrate just exactly how those solutions could actually work. So again, we need to get back to basics. So my last slide is, if you're interested in the details of some of our current work on these issues, here's simply a recent paper of potential interest. And thank you,
Harlan.
So Harlan, That was a great introduction to my presentation on the intersection between data protection laws and regulations and the use of AI technologies. What I thought I would do in this segment is really focus on that intersection and to really put shine a light on the fact that the AI systems, or many of them that we've heard about today, actually the inputs are personal data, and the outputs as well from these AI systems. Many of them constitute personal data. You know, these outputs representing statistical guesses, not factual information about individuals, and they're used to classify people, make predictions about people, make judgments and decisions affecting people. So from a data protection perspective, one might think of an AI system as actually manufacturing personal data about an individual. So recognizing that there are lots of positives, as Harlan just mentioned, there are also risks with respect to unfair discriminatory outcomes, perpetuation of existing socioeconomic disparities. So data protection regulators across the globe are actually beginning to address the use of AI technologies, attempting to mitigate those risks, recognizing that AI technologies are really becoming increasingly sophisticated and widespread. So the focus of looking at, or my reason for wanting to compare different countries and how they regulate AI is that I think putting some attention to the similarities and the differences is useful in helping guide organizations, guiding policymakers with respect to how to comply with data protection rules and principles and ethical requirements with respect to the use of AI. To that end, in this presentation, I'd like to look quickly at the FTC, the Federal Trade Commission here in the US. I'd like to look at the UK's Information Commissioner's Office and how they are approaching AI regulation. And then the last would be the Singapore Personal Data Protection Commission. I chose these three because each represents influential data protection regulators. So with respect to the next slide, with respect to the Federal Trade Commission, they will be the first to recognize that they've had a long-standing relationship with regulating algorithms in the financial sector. And that is through their enforcement powers with respect to the Fair Credit Reporting Act. In their role as an enforcer of the Federal Trade Commission Act, which prohibits unfair and deceptive trade practices, they also have played the leading role here in the US with respect to data protection regulation. So they recently, as recent as April of this year, issued a guidance which set forth some key principles, and they're listed here on the slide. And they may look familiar to some who are familiar with the Fair Information Privacy Practices, but they go a bit further, and they actually build upon some of the principles in the Fair Credit Reporting Act. The guidance, however, fell short, in my view, in terms of really not being very specific and helpful and useful in addressing the unique challenges in the AI context. Other than this FTC Act, there really is no comprehensive federal data protection regulation with respect to AI here in the US. So turning our attention to the UK, which has as its lead data protection enforcer the Information Commissioner's Office, they've actually been leading the way, I think, in the world around regulation of AI, again, from a data protection compliance perspective. In other words, trying to address the risks to fundamental rights and freedoms of individuals, the kinds of interests and rights that Harlan was focusing on in his presentation. And in their work, they have come up with an auditing framework, which actually is useful for them in terms of auditing organizations that are actually using AI to make sure that the organizations are complying with the Data Protection Act in the UK and the GDPR, which is the European data protection law. And what they do is really, I think, do a really good job of drilling down into some of these more nuanced issues with respect to what constitutes fair, lawful, and transparent processing. They dive deeply into this explainability issue that was first discussed today by Carla Bradley. And one of the things I really liked about the UK is they really brought forward this concept of a data protection impact assessment when an organization is either developing or deploying some AI technology. And
Thank
they
you,
also, yep.
We'll go to some questions and let all the speakers respond. So actually the
terrific.
Yep.
Thank you.
So the first one I will pose to you is, can you address the implications of the use of AI technologies in education with regards to the protection of FERPA data?
Yes, very, very timely subject, isn't it?
Yes.
Yeah, it comes up in the context of both FERPA and also it comes up in the connection of compliance with myriad state laws that actually go further than FERPA in actually addressing the online providers who are actually providing these different solutions that are being used to collect information for useful educational purposes. But the use of that information for purposes of better informing their algorithms to better inform teachers and educators about their performance. It's an area of increasing interest at both a federal, the federal law here is FERPA, as you mentioned, but there are various state enactments of FERPA and other laws like the California Student Information Privacy Act, which has been found in, which has been actually followed in a lot of other states, including Maine.
Excellent, great, thank you. So second question addressed to Jim. How are the ethical and social aspects being integrated into K through 16 education focused on computing, AI, and so on?
I'm not directly in the area of dealing with how to integrate this into the education system, but unfortunately, ethics has not received a very high visibility in any level of education, university down. And so the social impact issues are both of high concern, and I'll give you a quick example of that in a minute, and not formally put into the curriculum at almost any level short of the university, where you typically do get ethics as a topic. I'll give you a quick example. I'm now judging the Young Inventors program here in New Hampshire, and one of the inventors was demonstrating a machine that would go next to your mailbox and be used to immediately shred junk mail, so that your personal information on that junk mail would not end up in your waste paper basket, visible to somebody who might read that. Yeah, for a fourth grader, I thought that was a wonderful understanding of privacy issues, and I'll take it. But yeah, it goes much deeper. And the problem is that until people understand the kind of issues that Peter and others have raised here, and Peter's comment about the manufacturing of personal data is dead on. So people understand that that's what AI is doing on a broad basis across the board in our online systems and how that impacts their lives, they're basically running blind. They're not in a position to apply an informed consumer or informed voter understanding of what's going on.
Great. Harlan, would you like to add to that?
Well, a couple of things. Yes, certainly the ethics are something that we're dealing with in the computer science curriculum as mandated, of course, by Abedi accreditation. And we spend a huge amount of time. We make sure our computer science students are at a level high enough to really understand computer science. So we typically teach this at the junior, senior level, really delving into the ethics, the ramifications of these technologies that you are going to be helping foist on the world. So certainly at that level, we're doing that. Somebody had raised the issue of ethics before, and of course, when we're dealing with ethics, we're talking about concepts like justice, non-malfeasance, beneficence, but one of the key ones here is autonomy of the individual in these instances. So one of the things we've been focused on is really trying to say, all right, so how can we enable individuals much greater control over their own information exposure? And what's the legal technological model that would allow us to best enable that? And then we can start talking about different legal paradigms, whether they're in the GDPR in Europe, the UK, Singapore, the US constitutional system. What are some solutions that we can actually pursue right now? And I think if we get back to the kind of basic ethical foundations, they provide us, the philosophers actually provide us with some very substantive direction for us to move in for the engineering, software engineering community, as well as the business community, where we need to be heading.
Thank you, Arlen. Let me pose this last question to all of you, and let's start with Peter. Can you touch upon ways in which data privacy laws and standards are being upheld in applications such as autonomous vehicles and so on? Peter,
yeah, that's a great question. The reality is there really isn't any case law that's developing in this area just yet. And there's a lot of self-regulatory approaches. For example, in the automotive area, there's been for quite some time now, a self-regulatory approach to how to manage all the data and how to find ways to provide the right calibration with respect to both security of that data as well as the privacy implications of collecting all that data about individuals. Most of the self-regulatory approaches, most of the ways in which regulators are thinking about this globally, really come down to the tenets that are set forth by the FTC. The transparency, the notice, right? The explainability, making sure consumers are aware of what actually is being captured. But there are real challenges in the AI area in terms of matching the AI context to non-AI contexts in which we are familiar. So mapping the FIPS, for example, the Fair Information Privacy Practices, to AI, it's not a complete solution by any stretch. And I think regulators and consumers and manufacturers of these, the users of these AI technologies are realizing that and building into their compliance programs something that is sensitive to the different governance frameworks that are being developed.
Thank you. I'll hand it off to my colleague, Ali Abedi, and he'll wrap up.
Thank you very much,
Thank you.
Aline. I would like to thank all the panelists today for the great presentation, and also my fellow moderators for giving us some time. Also, thanks everyone to all the attendees today, and with your very thoughtful questions, we'll make sure that the unanswered questions will be answered on our website. I would like to thank Office of the Vice President for Research for hosting this webinar, Dr. Cody Bahramian, for his vision behind this webinar. Also my colleagues, Tammy Crosby and Tilan Hobson on the back end that were basically organizing and coordinating all this. So this webinar was the tip of the iceberg. We tried to barely scratch different aspects of a very broad area of AI and machine learning. In the fall, we are hoping to start a seminar series which will be dedicated to one topic at a time with more depth. So look for more announcements. And again, thanks very much for joining us. And this will conclude our AI webinar for today. Have a great day.